Okay, so section 7.2, we're going to continue talking about radicals like we just were, but now we're going to explore a relationship between radicals and a notation that we're already familiar with. So what we're going to do is we're going to look at rational exponents. And we just spent the chapter talking about rational numbers. Rational numbers are numbers that are rational expressions was the last unit, and that was expressions that can be written as a fraction. So the word rational here is the same connotation. So what we're going to look at is, for the first time in this class, what happens if I have a number and then my exponent is not an integer, a positive or a negative whole number, but what happens if it is a fraction? So 9 to the 1/2 power. Okay, well, the good news is that since we just introduced ourselves to radicals in the previous section, there is just one little bit of new information to this problem. And that new information is this: when you have a fraction in your exponent, the denominator of the fraction is the degree of the radical. So a fractional exponent is telling you to take a root. Okay, so there's a relationship between this and what we just did. So I'm going to rewrite this because I don't think about fractional exponents this way. I would convert it because my brain is more familiar with the radical. So here's what I'm going to do. I'm going to put my radical. I'm going to put the 9 under the radical, and then this 2 means that it's going. I'll write it on this one. It means it's going to be a square root. Now, again, you don't usually write the 2 for a square root, but I am on this problem just to show you where the 2 went. So now that we've got that, this is the square root of 9. We've already answered this question in the previous section. What times itself 2 times gives you 9, and that is 3. So I'm just going to write, 2 or 3, and then you're going to do them, and then I've got 2 or 3 more that you're going to do just to get used to this new notation. That's all this is it's a new notation for something we already talked about. So try these first couple. Let's say that you have 81 to the 1/2 power. What I would like you to do is write it as a radical. Practice doing that. Let's say you have 125 to the 1/3 power. We've calculated both of those. The new thing here is write it as a radical first. All right, 81 to the 1/2. How do we rewrite that as a radical? What does it become? (81) under the radical, and then the index is 2. So I'm just going to leave that blank right there because not writing it is the same thing as it being 2. So it's the square root of 81, which we've seen previously as 9. Again, don't go any further. Sometimes students want to put a radical over that. Once you've taken the root, the radical's done. Okay, so you wouldn't now put a radical and go, oh, square root of 9 is 3. That's not how radicals work. So don't go too far with that. That is sometimes a mistake students will make when they see the number 9 or something else you could take the square root of. The next one, I've got 125 to the 1/3 power. So I'm going to have the radical with 125, but this time, what am I going to put in the basket here of the radical? I'm going to put a 3 in. Yep, that's reminding me to take a cube root. Okay, what number times itself 3 times? And again, we did this earlier in the previous unit. What times itself 3 times gives you 125? And that is 5. 5 times 5 times 5. So we're just making this link that the denominator of a fraction becomes the index of the radical. Okay, they mean the same thing. It's just different notation. That means the same thing. So here's a few more. I just want to make sure I cover all the bases on different things that you'll see. So negative 125 to the 1/3, and then 625 to the 1/4 power. Negative 25 in parentheses to the 1/2. Those parentheses are significant. And then negative 25 to the 1/2. Okay. If you don't see the difference between those last couple, that's okay. That's why there are examples for us. All right, so the first one is negative 125 to the 1/3. What these parentheses mean around it is that all of this that's under in the parentheses is under the radical. So I have a radical negative 125 because the negative is with the 125 in the parentheses, and then I'm going to take that third root, the cube root. So what times itself 3 times gives you negative 125, and that is going to be negative 5 times negative 5 times negative 5. Next one, I've changed the index to a 4. So I've got my radical with a 625, and then I'm in the basket, I'm going to put a 4. And then this is just, I mean, I know it's a new number. We haven't done this one yet. This is just messing around with your calculator to figure out what number times itself 4 times gives you that. And it's going to be 5. Now, these last two are very important for us to understand the difference of these. Okay, so I'm going to set both of them up as radicals first, and then hopefully it looks familiar. It's going to be just what we talked about in the last section. So again, this negative is inside parentheses. So this is saying all of this is being raised to the 1/2 power. So I have a square root, and then the negative 25 goes under the radical. This one, the negative, is not encapsulated in parentheses. So the way you approach this is I forget about the negative for a moment, just cover it up with your thumb. And what I have is 25 to the 1/2. So that's the square root of 25. And then since this negative is out front, it just goes out front here. So that's the difference, and it's important to distinguish because similar things to this will occur frequently in this section when we're talking about radicals. When something's in parentheses, that means that whole thing is being raised to the power. When it's not in parentheses, it just means that whatever is directly below the exponent is what you're raising to the power. So in this case, just the 25. Well, last section, one of these we can do, one of these we cannot do. Which one can we not do? The top one or the bottom one? Oh, top one. When the negative is under an even index, this is not defined. This one, when the negative is out front, again, that just says the square root of 25 is 5. 5 times 5 is 25, and I'm going to make that negative. So far here, there's been no new information as far as the arithmetic is concerned. The new information is the notation. When you have a fractional exponent, that becomes the index of your radical. So all that to do this now. Let's say that I have 9. Now, instead of raising 9 to the 1/2 power like we did a few minutes ago, we're going to raise it to the 3/2 power. That's the next problem. All right, 9 to the 3/2 power. Okay, well, let's look at this then. Told you previously, and it still holds, is that whatever the denominator of the fraction is, this is the degree of the radical. So this is still going to be a square root. Now, what remains to be seen is what do I do with the 3? Well, you can do one of two things. One is going to be easier to do the calculating than the other, but they're both right. So I have the square root. The denominator became the degree. I'll put the 2 in on this problem. And then I have the square root of 9 to the 3rd power. The numerator of the fraction is just the power. Well, in this format, I don't know about you, but I'm not good at multiplying 9 times 9 times 9. It's a very large number, so I'm not going to be able to do that in my head. So what you can do is this. You can do the square root of 9 and then do the 3rd power second. It doesn't matter what order you do the square root and you do the exponent. They're on the same level of the order of operations. And the reason this is handy is because now the square root of 9, we can do that. We've talked about that one a couple times. 3 times 3 is 9. And then 3 to the 3rd power, 3 times 3 times 3 is 27. So here's a few problems to do numerically. Here's your first one. I would like you to calculate what 8 to the 5/3 power is. Which one of the numbers, the 5 or the 3, becomes the index of my radical? The denominator. It's always the denominator is the index of the radical, every time. So this is going to be the cube root of 8. And then I'm going to put this on the outside because I can do the cube root of 8 mentally. We've already done it like 3 or 4 times. And then on the outside, I'm going to raise that to the 5th power. So there's my 5, there's my 3 5/3. The index of the radical is always the denominator of the fraction. So then, what's the cube root of 8? What times itself 3 times gives you 8? And now I'm going to have 2 to the 5th. Your calculator can tell you what this is. 2 times 2 times 2 times 2 times 2. That's going to be 32. Here's another one. I'm going to practice this because it's new and different and fun. So let's try this. I would like you to do 100 to the 3/2 power. And then once you've given that a try, I would like you to please do negative 125 to the 2/3 power. And while you're doing those, I'm going to run and get you a drink of water. All right, the first one, 100 to the 3/2 power. Which number, the 3 or the 2, becomes the index of my radical? 2. It's always the denominator. So it's going to be the square root of 100. Then raise that to the 3rd power. So the square root of 100, what times itself 2 times gives you 100, and that's going to be 10. And then 10 raised to the 3rd power, your calculator will tell you that that is 1,000. 10 times 10 times 10. The next problem, I've got negative 125 to the 2/3. Which number, the 2 or the 3, is the index of my radical? The 3, it's always the denominator. So this is the cube root of negative 125. Remember, that is doable. It's an odd index. You can have a negative number when it's odd. And then we're going to raise that to the 2nd power. So the cube root of negative 125, we've done this one a couple times. 5 times 5 times 5 gives you 125. So it's going to be negative 5. And then I'm going to raise that to the 2nd power, because that's what the 2 in the numerator of the fraction tells me. So negative 5 times negative 5 becomes 25. So there's the link between fractional exponents and radicals. And what we're going to do, we got about 30 minutes or so, but I know I have to pass back tests. So I've got a little less than that. All we're going to do now, since we're talking about exponents again, is we're just going to remind ourselves of how exponents work. And we're going to practice that with some problems. So what I mean is this. Forget the fractional exponents for just a minute. I'm just going to take us back to chapter 4. We did a section, and there are 4 properties of exponents. I just want to review real quick. The product rule. You have this in your notes, but if you want to write it down again, that's fine. The product rule says this: if I have, if I have x to the 5th times x to the 3rd. What do you do with the exponents when you multiply your bases? You add them, indeed. So that is x to the 5 plus 3 or 8. Okay, the product rule is you add the exponents when you multiply the bases. The quotient rule. What the quotient rule says is something similar. This time, though, instead of instead of multiplying the bases, we are dividing. So if I have y to the 9th divided by y to the 4th. The quotient rule says to do what with the exponents when I divide the bases? To subtract them. Yes, so it's y to the 9 minus 4 or 5. Then I have the power rule. And the power rule says if I have something like 5 to the 2nd power, then I raise it to the 4th power. So I have a power raised directly to another power. What do I do with the exponents in that case? You multiply them, yes. So that's 5 to the 8th power. And last but not least, we have the negative power rule. Or the negative, let's say exponent, because I don't want to get confused with the power rule. The negative exponent rule. If I have something like 2 to the negative 4th power, what do you do anytime you have a negative exponent? What does that mean? This is a good review for the final exam. Glad we're talking about it. A negative exponent tells you your base is in the wrong place. Okay, it's in the wrong position. So a negative exponent means you got to take the reciprocal of your base. So instead of a 2, it's going to be 1 over 2 to the 4th power. Okay, that was what we talked about in section 4.1 several weeks ago. And then I can do that. 2 times 2 times 2 times 2 is 16. So that's 1 over 16. So those are my 4 basic properties of exponents. So now what we're going to do, and you're going to do this, and then I'm going to help you check to see that you did it right. We're going to do this now with our fractional exponents. So here's a first problem, nice and relaxing for you. We're going to start off with a nice common denominator problem. So let's say that I have 2 to the 1/4 power times 2 to the 2/4 power. I've already gone through and gotten the common denominator on this first one for you. so that we can get a little confidence. Okay, so when I multiply the bases, I add the exponents. So my base doesn't change. The base is still going to be 2, but then I have 1/4 plus 2/4. Let me do this on scratch paper instead of trying to do it small there. So I add the exponents. So I've got 1/4 plus 2/4. Well, we just spent a unit talking about fractions. I've got a common denominator. When you have the common denominator, that means you just add the numerators. 1 plus 2 is 3 over 4. So this is 2 to the 3/4 power. Done. All right, we'll try this one. This is a pair, and they do not have a common denominator. Okay, but the denominator's not too terrible bad for you. So let's try this. Let's try 3 to the 1/2 power times 3 to the 2/5 power. All right, so I'm multiplying the bases, so I add the exponents. So my base is 3. My base is going to stay 3. And what I need to do is add these exponents. So I have to take 1/2 and I need to add a 2/5. Well, what's the common denominator? What's the common multiple between 2 and 5? 10, sure. Again, we just spent a section in the last unit adding fractions. These ones just have numbers. So here we go. 2 times 5 is 10. So in the top, 1 times 5 is 5 over 10. On the second fraction, 5 times 2 gives me 10. So in the top, 2 times 2 gives me 4. And now I add these two fractions. I've got 5 over 10 plus 4 over 10. 5 plus 4 is 9 over 10. 3 to the 9/10 power. Here's a quotient rule problem for you to do. Already in your notes, if you wrote it down, you know that the quotient rule is when you divide the bases, you subtract the exponents. So if you have x to the 5/6 power divided by x to the 1/10 power, go ahead and divide those two things, please. All right, quotient rule says when you divide the bases like we're doing now, you subtract the exponents. So my base is x, so my base will stay x. Then I have 5/6 minus 1 over 10. What's the common multiple between 6 and 10? You can use 60, or you can use any common multiple, but I'm going to use the lowest. I'm going to use 30. Okay, so if you just multiply these two things together and use 60, that will work. Okay, you just have a little more reducing to do. I'm going to use 30. So 6 times 5 is 30. So in the top, 5 times 5 is 25 over 30. Here, 10 times 3 is 30. So 1 times 3 is 3 over 30. And so when I subtract those, 25 minus 3 is 22 over 30. And that's great. You're almost done. I just need to reduce that. 2 goes into both of those. So when I divide by 2 in the top and the bottom, 22 divided by 2 is 11. And then 30 divided by 2 is 15. So that is my new exponent. Here's a power rule problem. In your notes, it tells you what to do with the power rule. When you have something to a power raised directly to another power, you multiply the exponents. So if I have x to the 4/7 raised to the 5/2 power, okay, power rule says when you have something raised to a power, raised directly to another power, you multiply. So my base is x, my base is going to stay x. And so now what I have to do is I have to multiply 4/7 times 5/2. Now, if you struggle with your arithmetic on fractions, I have some videos I can share with you. That's fine. Just email me and I can send you some links to things that'll help. You have two options here. Remember, to multiply fractions, you multiply your tops, you multiply your bottoms. That's how you multiply fractions. So if you want to do that, you have 4 times 5 is 20 in the top, 7 times 2 is 14 in the bottom. That's great. And then you reduce. I like to reduce first because I like to work with numbers that are smaller when I'm able to. Doesn't matter. Neither way is righter or wronger than the other. Okay, so do whatever you're comfortable with. But I'm going to reduce first. I notice 2 goes into 2 once, 2 goes into 4 twice. Okay, so I reduced. Now I'm ready to multiply. In the top, 2 times 5 is 10. 7 times 1 is 7. So I've got 10 over 7 is my exponent. All right, I've got like 3 or 4 more problems, just depending on what time allots us. All we're doing now is practicing these properties of exponents. That's it. Okay, so if you're struggling with them, that's okay. That's why we're going to practice a little more. Here's a problem that incorporates both the power rule and the quotient rule at different steps. So you're going to do this for me. We've got in parentheses, we've got r to the 2/3 power, and then t to the 1/4 power. And we're raising that whole thing to the 4th. There's power rule. And then divided by, once you've done that, divide by t to the 3rd. So you're going to do this in 2 steps. In the top, you're going to apply the power rule and simplify that, get rid of those parentheses. And then in the bottom, and then once you've done that, you're going to apply the quotient rule to one of those factors. I'm going to give you a couple minutes to make some headway. Do as much of that as you can possibly do. right? So I'm going to apply the power rule first on this. So in the numerator, I've got R. Now, don't be afraid to use your scratch work. I'm just going to come down here and do all my calculating down here. So I've got 2/3 times 4. So 2/3 times 4, which I'm going to write as 4 over 1. Nothing cancels here. There's nothing the same in the top and the bottom. So what I've got is 2 times 4 is 8. 3 times 1 is 3. So I have R to the 8/3 power. Then I have a T. And I've got T to the 1/4 raised to the 4. So that is 1/4 times 4 over 1. Well, these 4s are the same. So 4 goes into 4 once. 4 goes into 4 once. So I have 1 over 1, which is just 1. I'll write the 1 here so you know where it went, but we don't usually write 1 as an exponent. It's implied when there's nothing else there. And then there's nothing on the bottom. The t to the third is not in the parentheses, so I've got t to the third. There's step 1. I applied the power rule to that problem. Step 2 is I do have the opportunity to do the quotient rule. I've got these t's. So I've got r to the 8/3, and then t, remember when we divide the bases, we subtract the exponents. So I have 1 minus 3, 1 in the top minus 3 in the bottom. And your calculator will tell you 1 minus 3 is -2. And if you've done all that, you've done all the hard work. There's just one more step. We don't leave negative exponents. That's considered not simplified. So I'm going to now, the r to the 8/3, it's bored. It's just been sitting there. The t to the -2 goes down to the bottom and becomes t squared. And there we're done. Try this problem. It's a similar sort of concept. It's just applying the power rule and the quotient rule, just so that you get some practice at it. So this problem says the following. In parentheses, I've got this. I've got a to the second, b to the -4th, over a to the -2, b to the 8th, and all of that is being raised to the -1/2 power. Now I'm going to tell you what I'm going to do. There's other ways to approach this problem, but what I'm going to do is I'm going to get rid of the parentheses first by applying the power rule. So I'm going to first do the power rule on this -1/2. Then I will do the quotient rule second. Okay? You might be thinking, hey, Perkster, could I do the quotient rule first? Could I do the stuff inside the parentheses first? And the answer is yes. And then you could apply the power second. But I'm going to do the power rule first when I do it. All right, here goes. I'm going to apply the power rule first. So I've got 4 things in the parentheses to apply the power rule first. So in the top, I've got this a. It's 8 to the second raised to the negative 1/2. So I'm just going to come here to my scrap work. I've got 2, which is 2 over 1 times negative 1/2. Well, a positive number times a negative number is going to be a negative. And then here, 2 goes into 2 ones, 2 goes into 2 ones, so I have negative 1. So that's a to the negative 1 power to start off. Then I've got a b to the negative 4th, so that is negative 4 over 1 times the negative 1/2, which is the power I'm raising everything to. This time, a negative times a negative is a positive. I'm going to write a plus here so that you know I'm not going to write it up there, but I'm going to write it right here. And then 2 goes into 2 once, 2 goes into 4 twice, so I have positive 2. In the denominator, I have a to the negative 2. I'm going to just erase this top one, just to have some scrap room. So I have negative 2, so that's negative 2 over 1 times this negative 1/2, that's out there. And again, a negative times a negative is a positive. And these 2's cancel again, so that just leaves me positive 1. And then last but not least, I've got b to the 8th. So this is 8 times the negative 1/2. So I've got 8 is 8 over 1 times negative 1/2. A positive times a negative is a negative. 2 goes into 2 once, 2 goes into 8 4 times, so I have negative 4. So on this problem, just because of the numbers that were picked, we end up with our second step that actually doesn't have any fractions. That's nice. The less I have to deal with fractions, the better. But I do have the quotient rule to deal with. So I've got a to the negative 1 minus 1. So a negative 1 in the top minus this one. So negative 1 minus 1 is negative 2. Your calculator can tell you that. Don't be afraid to use your calculator. Then I have b to the 2 minus negative 4. I've got a 2 in the top minus negative 4. So that's 2 plus 4, or 6. And then once again, we don't leave negative exponents. It's considered unsimplified. So the b to the 6th is the top. The a to the 2nd goes to the bottom. All right, we got one more problem on our agenda for the day. This is the last one. So I would like you to do this for me. Let's say you have x to the 2/3 power. You're raising that to the 2nd. And then in the denominator, you have x to the 2nd raised to the 7/3 power. So again, it's product rule, and, it's power rule and quotient rule, as we've done a couple other times. All right, just for time's sake, I've got x to the 2/3 squared, so that's x. 2/3 raised to the second power, that is the power rule, so 2/3 times 2/1. Nothing reduces there. 2 times 2 is 4. 3 times 1 is 3. So I have x to the 4/3 in the top. In the denominator, I've got x again, and this time I've got second raised to the 7/3 power, so that's 2/1 times 7/3. Again, nothing cancels, so 2 times 7 is 14. 1 times 3 is 3, so I have 14/3. So that was the power rule applied to both the numerator and denominator. And then finally, I'm dividing, so it's a quotient rule problem. So I need to subtract, so I have 4/3 minus 14/3. Well, those have the common denominator, so we saved ourselves a little work here. So 4/3 minus 14, 4 minus 14 is -10/3. And once final time, a negative exponent is not considered simplified, so it becomes 1 over x to the 10/3. And there we go.